In this example, we'll take a closer look at the vertex form of a quadratic and how to determine the vertex from the vertex form. So that's the task. We're given a couple of functions here and we're asked to determine the vertex of each of the functions. So remember that general form for the vertex form of a quadratic? So we have a times x minus h quantity squared plus k, and the vertex is hk, right? So with that reasoning, if we look at this function f of x equal to negative quantity x minus 3 squared plus 11, then 311 would be the vertex of the function, would it not? Yes. With the function g of x equal to 1/3 x plus 2 quantity squared minus 7, the vertex would be, careful here, -2, -7, right? Okay, now what happened there? Because we got to look at that form, right? The a times x minus h quantity squared, and we have x plus 2 instead of x minus 2. Okay, so I'm going to rewrite this a little bit just so we can see it. What's happening there. It's the same thing as subtracting a -2. You can think about it that way. Right, subtracting a negative is the same thing as adding. So if we're thinking about our h value in this case as being -2, then it works, right? And the y value, we're subtracting 7, right? So the y value will be -7 in this case. Okay, so from an algebraic perspective, that's what you want to be looking at. The other thing that I always try to keep in mind and see in my head as I'm doing these things, each one of these functions relates to the basic graph of x squared, right? So we're taking x squared, and to get a vertex of 311, we have to move it to the right 3 units and up 11 units, right? And to get a vertex of -2, -7, we have to move it to the left 2 units and down 7 units, right? So more on that in a little bit, but if that's helpful for you to kind of play around with these, graph them, and also graph x squared, just plain old y equal x squared along with it, and see how they relate.